Helen. Block 2. Good evening, welcome in RNQ Isino classes, Block 2, Unit 4, Key Issues in Philosophy of Science. 4.1 Introduction. Philosophy of Science is interpreted as a critique of science. Another interpretation is that it is an inductive metaphysics. The third interpretation is that it is a pragmatic of science as a critique of science. It analyzes the language of science, the semantics and scientifics of scientific language is analyzed as an inductive metaphysics. It uses the inductive method of science, but unlike science, it focuses on the study of transcendental entities. Also, the key issues in philosophy of science include scientific method, discovery of theory in science, structure and validations of scientific theory and scientific explanations as pragmatics of science. Philosophy of science tries to relate the findings of the scientist to the human welfare and upliftment. 4.2 Discovery of theory of science. The philosopher science consider the various science as finished products of historical process. The historical order of development is determined by curiosity, accident, or a pressure of necessity. Science explains while philosophy tries to understand all scientific theories can be traceable to the acceptance of for matters of facts that something exists, that something can be known, that there is something which matters, and that something makes sense and can be reflected upon. The above four matters of fact correspond to four branches of philosophy. Ontology, or the theory of being, deals with what exists. Epistemology, or the theory of knowledge, deals with what can be known. The theory of value, sometimes called axiology. Logic, science, scientific knowledge is empirical. There are three problematic steps to the examine the step from any experience at all to experience of a world of one's on the step from experience of what would to knowledge of it, and the step from knowledge of that would to knowledge of a word it common. 4.3 Perception, thought and language. In order to understand the transitions from experience to knowledge, it is necessary to put ourselves in a positions of experiencing. For this purpose, Edmond Husserl recommended a process called bracketing. This means forgetting all that one has learned in order to take an unprejudiced look at what is presented phenomenologically. The objects perceived are international objects. The world of phenomena reveals the properties, configurations, process, sequences, etc. of the objects. Perception means a grasping of something through the senses. Perception, sensations, and interpretation. However, the perceptual experience of the world is incomplete because of the sense data thought of mechanism for the synthesis of all full world out of these bits and pieces of experience. It is regarded as the second convenient hypothesis. The external world was the first concept, are a set of hypothetical entities which correspond to perspective concept function through recognition, identification, and representation. Concepts have ontological status. The three essential ingredients: the sign, the thing, which is the sign of the person to whom it is understood, meanings constitutes the language, the realms corresponding to object, sign and interpreter are precept, term and concept which can be connected in the following way. All language began as ordinary language under the pressure of the immediate necessity of communication. Some prospects have corresponding concept and terms, but it is possible to observe terms and concepts without corresponding respects. The language of science is a standard language. It has its own special vocabulary referring to particular kinds of objects, and process of language which is being used to talk about the world is called and subject language. The language which we use to discuss this first language is then called a meta language. For instance, the sentence copper sulfate is ever solvable is a metalinguistic philosophic remark, mentioning a scientific sentence belonging to the object language which actually says something about copper sulfate. The correlations of perception, thought, and language. Starting from perception, science proceeds to the constructions of conceptual schemes whose order reflects the order of perception, and links these with specialized language for the purposes of making prediction. Language, thought and precept can stand alone in the conditions of awareness in our aesthetic experience. We are able to concentrate on perceptions to the exclusion of language and conceptual thought. In logic, two systems are said to be isomorphic if very element one system can be matched with a unique element of the other, and vice versa. A rule, the use of language for the expression of thought and the descriptions of perceptions. A rule linking thought of perception, thought, and language. The following kinds of relations are relevant: logical and grammatical relations in language, spatial and temporal relations in perception, whatever physiological theory calls for in thought. Classification: the relations between the term and the object to which it refers in perceptions may be thought of as a one-to-one relations, but this is obviously a gross oversimplification. To begin with, words do not exist as single entities but as collections of utterances and inscriptions, each one a particular use of the word on a particular occasions. Or distinction has been made between the word type which is embodied on each such occasions, and the word token which is its concrete physical embodiment as an individual sound or mark. The token is a sign in the original sense. The type belongs to language. On a more abstract level, Aristotle developed a theory of universals in the things. According to this theory, everything was a combination of two elements, forms and matter. The matter accounting for the things being a real thing in the world, and the form accounting for its being the kind of thing it was, and thus playing the parts of the universal. The forms were arranged in a hierarchy of definitions of genius and species, as it's still done for the animal and plant words, everything having its place in a logical order. What science aims at, it is the development of concept which will stand for any individual in a particular class on the assumption that there is a similarity between the members of the class, which entails similarity in their behavior under similar circumstances. We may distinguish for different senses of similarity in descending order of usefulness for purposes of classification. The first may be called genetic similarity. This is between objects having similar origins. The second, structural similarity between objects having similar constituent parts of similar relations between their parts. The third is the functional similar between objects having similar behavior. Definition: the class of actual object or events to the members of which a term applies correctly is called the denominations of that term, and while the term denotes the objects in questions, the objects constitute the definitions of the term. On the most primitive level, a term may be defined by pointing out something to which it applies, that is by showing its meaning, and this procedure is known as ostensive definition. X zebra is meant animal, or stripped or four-legged terms can be defined away from means of other terms, but there will be at least some terms left for which no such definitions are available. A list of the properties which an object must possess if it is to be included in the denotations of some intentions. The extensions of term is the class of all possible object, past or future, known or unknown, which is, if they existed, would belong to its denotation. The connotations of a term is specified by a list of the properties which the members of its denotation happen to have in common, including those properties which constitute intention definitions of terms by reference to other terms belonging to the same language systems are inter, internal definitions which go outside the language are external definitions where a term is definition by means of other terms. The original term, the defined term, that which is to be a defined, is eliminable in favor of the term or terms used to be defined. If the defines a contextual occurs, the decision to call the element of atomic number 100 fermium was a speculative definitions both in the internal and external senses. Internally, because it enables scientists to replace locations such as the one above or the next element after Einsteinium by the term fermium, and external because there is an actual substance which is named fermium in lexical definitions. The definitions of a term is derived from a dictionary. In a historical order of definition, theories were put together rather unsystematically, depending on accidents of discovery, but in the heuristic order of definitions, new concepts are introduced in the most appropriate process. The introductions of a formalized language brings about the logical order of definition. 4.4 Generalizations, hypotheses, laws, principles, and theory. A scientist records his observation through a protocol sentence which asserts that something is in fact the case. A protocol sentence can be reached after something is in fact the case. A protocol sentence can be reached after a finite number of observations, and it must be intersubjectively corroborated and empirical generalizations. All as are B is arrived at after every individual observation. This is A is B, this A1 is B, all A's are B. One protocol sentence A1 is not B, contrary instance, is enough to ruin the empirical generalization. An empirical generalization might be defined as any sentence whose contradictory has the form of a protocol sentence, sometimes sentence of the form if a then. B will also be protocol sentence about electron are given the status of hypothesis. Science electron is not observable. Hypothesis always contain theoretical terms, since any universal sentence containing only observation terms should necessarily have a protocol type sentence. For is contradictory. Not all sentences containing theoretical terms or propositions about theoretical constructs are hypotheses. Only those from which empirical generalization follow the truth or falsity of a sentence does not affect its logical classifications and test of truth or falsity on empirical grounds don't belong to logic. A hypothesis may become a generalization through the Refinement of techniques of observation generalizations emerge naturally after a number of particular observation will hypotheses have to be invented. Anybody can make the jump from many to all, but it takes a genius to jump. ASHJG Thomson did from the discharge of electricity in gases to the electron. Every sentence of science falls into one or another of the categories: protocol, sentence, empirical, generalization, or hypothesis, laws, principles, and theory. A true empirical generalization, either affirmative all A's are B or conditional if A and B, called a law, which is accepted as true. The logical status of the scientific law depends on its being of generalizations and nothing else, but its historical status depends on what scientists of the period believe, and this reflects what we mean by scientific law. There are no immutable laws of nature, as only accepted generalization is defined as a law. The distinction between hypothesis and empirical generalization suggests a distinction between two different kinds of scientific law, one corresponding to empirical generalizations which are accepted to a true as true, and the other two hypotheses which are accepted as true. The law of conservation of energy is a hypothesis accepted as true. Since energy is not observed but rather the penetrations of balls is observed, principles are hypotheses accepted as suitable starting points for theoretical work. All generalization accepted as true have the status of laws, and all hypotheses accepted as true have the status of principles. A theory is a set of universal propositions asserted by means of a corresponding set of universal sentences. These sets are isomorphic with another. A theory is constantly changing. New laws are discovered, old ones discarded, or forgotten. Scientific theory finally constitutes a particular outlook on the world. The term comes from the Greek theorian. To look at scientific theory means knowledgeable outlook. There are other outlooks of the world also apart from the scientific outlook of the world. The structure of theory. 48, 49, 50, 51, 52. Protocol, sentence, empirical generalizations, and hypotheses have empirical content, but a scientific theory has a logical structure which can be abstracted from all empirical content and studied in isolation. So, theory is a structure of sentence without any accompanying scheme of constructs. The structure of the theory deals with the systematic internal organizations of theory. In the analysis of the structure of the we have to add one empirical truth and introduce a new kind of truth called logical truth. Formal logic in one which is concerned upon more with the relations of sentence rather than the content and meaning of sentence. A set of sentence in which the truth of the list of conclusions follows from the truth of the others. The premises is called an argument, and every inference may be expressed in an argument. Deductive logic serves for propositions and hence is often called propositional logic. It is also called sentential logic. Sentential logic does not look at the internal structure of sentence but their external relations. Predicate logic deals with the internal structure of sentence. Set theory, which is a recent development, is due to Boole, who contributed to the logic of classes. Sentential logic and predicate logic are both very ancient disciplines. The first was developed without using symbols by Aristotle, and the second by Stoics. The present formulation, the both the logic are due to Frege, Russell, and Whitehead. In a formalized language system, or calculus means a tool of calculation. The sentence from which calculation begins are called axioms, and a sentence arrived at according to the rules starting from the axioms is called theorem, and the series of sentence starting with axioms and ending with the theorem with exhibits the steps in the process is called a proof of the theorem. Pure logic is not interested in the empirical content, and therefore it is an Union-interpreted calculus. The concept with concept provides the calculus with an interpretations by following the rules of correspondence. A rule of correspondence is as kind of thing which establishes a relationship between the language we use to talk about the world and the language we use to exhibit purely logical truth. Sometimes the same calculus may have more than one interpretation. The calculus of which the kinetic theory of gases is an interpretation based on the domain of gas molecules is the same as that of which the theory of elastic collisions in Newtonian mechanics is an interpretation based on the domain of homogeneous spherical objects whose masses and elastic model are such as to allow them to undergo collision without permanent deformation and without fracture. It is only that the two caliculi have the same form, but they are the same caliculus. Therefore, it is possible to have the same model for two different caliculi in the structure of a theory. Measurement is used as a tool to explain the empirical phenomena. Measurement is a mathematical formalism in which what is qualitative observed is given in quantities. In measurement, a set of numbers operationally generated means nothing unless is taken as indicating a relationship between aspects of the world which in their theoretical setting. The concepts of measurement does not establish as connections between theory and the world. It establishes as connection between two theories, as connection between the numbers and what they stand for. Validations of theory. In scientific theory, the scheme of constructs is the customary interpretations of the logical calculus. The calculus has been developed to a point where, given suitable techniques of measurement, all the resources of mathematics main principle be brought to bear on the solutions of scientific problems. The truth of the calculus depends deductively on its axioms and as is asserted only hypothetically. In the validations of theory, we inquire how such a hypothetical system can be grounded in observation in such a way as to render it reliable as an instrument of explanations and predications. There are three indispensable qualifications which any sentence in the theory out to process. The sentence should be formally correct, relevant, and C. Reliable. Both discovery and structure of theory discuss at length the formal correctness and relevance of the sentence. So to scientific theory, the meaningfulness of a sentence lies in its verifiability, but the criterion of verifiability prevents universal statements from having any meaning. Science, all that can be confirmed in experience is particular. Therefore, the criterion was criterion was modified in the directions of the confirmation rather than of verifications. The introductions of conformability raised the questions as to how much evidence was required in order to say that a sentence was actually confirmed, and this led to the notions of degrees of conformity. This development gave rise to an important new branch of inductive logic, the logical problem of induction is inferring a universal statement from a number of particular instantations of it, but the inductive arguments may be strong or weak depending on the probability of their conclusion. A successful scientific theory is one which is practically useful for the society. The method of arriving at truth in science has the following pattern: hypothesis, deduction, and test. The scientific method has the following stages before arriving: scientific laws, observation, analysis, of empirical data, hypothesis, and law. Scientific method as a methodological inquiry aims at the reliability of explanations. It is also leading to intellectual exercise, trying down of abstract logical systems of empirical contents. In this sense, it is relevant to the validations of theory. 4.5 Scientific explanation. There are events taking place around us. These events evoke mm, curiosity in us. Therefore naturally we ask why at all the events are taking place the way we observe them. Common man can explain the events from his own perspective, but scientific explanations are different from the explanations of the common sense. Scientific explanations not only explain the present occurrence of events but also predicate the future occurrence of events. Some philosophers of science find asymmetry between explanations and predictions, but there are some who oppose such asymmetry between explanations and predictions. Those who hold the symmetry thesis believe that scientific explanations not only explains the present occurrence of events but also control the future events. Explanations of events and the descriptions of events are not the same. Those who describe the occurrence of events merely describe the state of affairs and do not go beyond it. Empirical phenomena which are explained can be classification as a physical B, biological, and C, social. The methodology adopted to explain the physical phenomena is not the same as the methodologies to be followed to explain biological and social phenomena. The Laird Morgan, according to the emergent theory, the constituents of objects will lead to the emergence of novelities, and hence the explanations is inadequate. The explanations must incorporate the noble qualities of the object for better understanding of the events around us. In statements such as laws from which explanation is deduced, it is called explanation. There is a logical relation between explanation and explanandum. The explanations of individuals' events is different from the explanations of scientific laws. Inductive and deductive are the two patterns of explanations. Inductive patterns is invariability connected to the probabilistic kind of explanation. There are many kinds of deductive pattern of explanations. There are four kinds of explanations: deductive, probabilistic, teleologicals, and genetic. Deductive explanation. In the deductive kind of explanation, the explain is a universal law of kind of explain in a universal law form, which explanation deduced for an explanandum x why the additions of the odd numbers always ends up with a square. 1 3 5 7 9 11. 1 is equal to 1 square. 1 is equal to 3 is equal to 2 square. 1 plus 3 plus 5 is equal to 3 square. 1 plus 3 plus 3 plus 5 plus 7 is equal to 4 2 square, etc. Here the explanandum is explained for an explanon which is universal law of mathematics. Example, why there is moisture on the outer surface of a glass tumbler whenever we pour ice water. Here the explainer in the premise is a law is physics law um, thermodynamics. When we pour ice water into a glass tumbler atmospheric water vapor comes into contact with the cooler part of the tumbler. The water vapor transforms into droplets of water, and hence there is a moisture on the outer surface of the tumbler. Why the percentage of the Catholics committing suicide was more than a Protestants during the last quarter of 19th century in England. Here the explanandum to be explained is related to historical fact. Therefore, the explained is a historical evidence from which explanation is deduced in the deductive pattern of explanations. The relations between explains and explanandum is logical. Therefore, this kind of explanations fulfills the rules of deductive logic for probabilistic explanation. In the case of deductive explanation, the explanation is deduced from the explanand, which is an invariability established. The law assigns the empirical validity of premise is not verified. The validity of explanation is taken for granted. Only the explanandum has the observational element, but in the probabilistic explanation there is a jump from some cases to all cases, that is from particular to universal. Inductive generalization is interpreted as probabilistic explanations when there is a jump from some to all, or from particular to universal. There is only inference and not certainty. X when we observe clouds causing rain in the present, we predict that there will be rain preceded by clouds, but sometimes there may be clouds not followed by rain. In this circumstance, we have to admit that there is no necessary relation between clouds and rain. So also, if a physician prescribes a drug for the present element, we can't say certainly that in future also the same drug will cure similar element. The drug may probably cure similar elements in future. The causal relations we observe between two sets of circumstances in the present may or may not be true in future. Under these circumstances, we cannot claim that there is a certainly for the future occurrence of events. Hampel's covering law model of explanation tries to establish a kind of logical necessary between explanations and predictions, but probabilistic explanation does not support any kind of necessary relation between explanation and predictions. The future occurrence of an event is only probably true. Some of our observations of clouds followed by rain in the present will hold good for the future only probably. Teleological explanation. Empirical statements which are purposive are called teleological statements. Why do we have lungs? The answer should give the purpose of the lungs in our body. The inhalations of air, so the oxygens can be utilized in blood circulation. Similarly, all parts of our body have specific functions. T perform the teleological or functional aspect is relevant not only to the parts of our body, but also the several natural or artificial objects around us. These objects have got functions to perform. In certain cases, the properties will be achieved. In future, the growth of paddy crops will lead to the yield of the grains of paddy. Therefore, the biological development of paddy crop is in the process of achieving a purpose. However, we can't say that any biological process will lead to only one purpose. Same biological function may lead to achieving several purposes. A particular biological structure has the function for a particular purpose. However, the same purpose can be achieved through different structure. For example, for the movement from one place to another, different living creatures have different structures. Man, cow, bird, snake, and fish have different structures for achieving the purpose of movement. Uh, the, there is no termini for biological functions. In other words, what is terminus for a particular biological function is the beginning for several other biological functions. For example, the corn seeds, which is the terminus for particular functions, may lead to be several other biological. In the case of physical and chemical phenomena, purpose invented by human beings. Most of the cosmic and astronomical phenomena are accidental in nature. Man carves out a pause in a purposeless natural phenomenon. Genetic explanation. Some of the questions can be answered only if we have the facts relating to the history of a phenomenon. For example, why is there Indo-Pakistan conflict, which resulted in three wars between the two countries? The answer can be given by tracing the history of India partitions of the country on the basis of religion, the earlier invasions of India by the Arabs, etc. In other words, explanations of this kind is based on the analysis of the genesis of the problem. Any phenomenon, whether it is physical, biological, or social, has its own evolutionary history. Unless we have the facts of the parts of a process, the explanations will not be adequate. The present circumstances offering an adequate explanation. Therefore, genetic explanation plays an important role in the explanations of social phenomena, in particular explanations of biological phenomena. Explanations of physical phenomena and the methodology adopted to do so is not sufficient. To the explanations of biological phenomena, mechanism interpretations of biological phenomena hold well when biological processes are understood in terms of physical and chemical concepts. In other words, reductionism is followed in understanding biological process, but reduction of biological process into physical and chemical process will lead to an explanation which is inadequate. Since biological phenomena are organism in nature, the whole is more than the sum of the parts. In organismic biology, the lower order of a biological system conditions the complex functions has purpose. All the individual systems perfectly coordinate in such a way that the human beings or any other biological organisms exhibit holistic activities. Mechanical explanations, however, are not contradictory in the explanations of biological phenomena. Understanding of the biological phenomena. 4.6 Methodological problems in social science. Physical and chemical events can be explained by following universal laws which are no, nomothetic in nature. Historical phenomena which are individualistic and unique cannot be explained on the basis of the laws governed by nomothetic science. Social science are ideographic in nature, and therefore the methodology adopted to explain such phenomena is different. Some of the methodological problems that arise when we explain social phenomena are controlled inquiry, subjective nature of social subject matter, knowledge of social pheno- phenomena are social variable value-oriented basis in social inquiry and cultural relativity and social laws controlled inquiry unlike in physics and chemistry wherein we can create experimental conditions at our will to conduct study. It is not possible to create experimental conditions in the study of society which consist of the groups of human individuals. They're all free thinking individuals having conclusions, goals of their own. Moreover, historical phenomena are unrepeatable. Various physical or chemical events can be repeated in the in the laboratories. Therefore, controlled inquiry is not practical. However, there are surveys conducted in societies by using some variables to find out some facts. Subjective nature of social or subject matter. The observations of social phenomena and the observations of physical and chemical phenomena are not the same. Human beings have got subjective attitude which may not be revealed in their overt behavior. J.V. Watson's behaviorism points out that man has got no inner or subject side for his behavior other than his overt behavior, but a man can pretend outwardly that he is a happy individual while inwardly he is sorrowful. In his context, a social scientist will not succeed in collecting complete data to draw conclusions. Knowledge of social phenomena as a social value. The individuals come to know beforehand that they are subject to questioning by social scientists for a specific inquiry. They may sometimes feed the scientist with false data, thereby distro-
स्प्रे मारो किसने क्या बनाया है
distorting the outcome of such inquiry. Korean Maggie
कौन बनाया देखो तो
Sephora. Value oriented base in social inquiry. Social scientists are based when reporting an event. It is not possible to get on based information about social phenomena. In fact, in the very selections of phenomena for study, the individuals are not free from value orientations. To frame universal laws on the basis of such based inquiry is meaningless. Cultural relativity and social laws. Physical and chemical laws are universal in nature, but it is very difficult to arrive in survival social laws because of cultural variations in the society. Each social, religious, and political group has its own laws. There are two uniform civil or moral laws universally applicable for all the societies. Therefore, explanations of social phenomena by following universal laws are not possible.
हेलो दादा
Good afternoon, sir.
गोविंद भाई कहाँ थे से दूध लाने दूध लाने गए
Requirements of scientific explanation. There are logical and epistemic requirements.
कपूर चाहिए
Requirements for scientific explanations. The logical requirements consist in having premises, explanants which are more general than the explanandum. The premises must contain at least one universal law. The epistemic requirements consist in the premises to be true. The premises must be known to be true. Both logical and epistemic requirements are necessary in scientific explanation.
गोविंद